This is the introduction to section 10.7. This is part 2. And as we look at part 2, we're going to discuss, in part 1 we talked about finding the areas of segments and the areas of circles, the area of sectors and circles. And today we're going to find the areas of segments. Now, what is a segment? A segment is a part of the circle that's bounded by an arc and the segment joining its endpoints. Now, as we look at this picture here, you see the segment of a circle. Essentially, the segment of a circle is any line drawn from one endpoint to another that's not through the center, so it's not a diameter, okay? And it's the area of that line to the outside of the circle. So you can see here where we have the segment of this circle. Here's one endpoint, and here's the second endpoint. This is our line drawn across. We want to find the area of this part of the circle. Now, in order to do that, what they're going to have you do is they're going to have the center here of the circle, and they're going to have you draw the two radii. So essentially from the endpoints to the center and the endpoint to the center. And now you'll notice if you include the whole thing here, that's the actual area of a sector. Okay, so you'll notice you have three things essentially. You have the sector, you have the segment. Remember, the sector is the whole thing. Okay, the sector includes from the center to the end point all the way around. Remember, it was a piece of the pie essentially. Okay, the segment is from one endpoint of a line to the other endpoint, not through the center. Okay, and that's this area right here, this yellowish green type color. Okay, that's the segment. And then you'll also notice that you have in here a triangle as well. So what you're going to find out here as we go through and figure out how are we going to figure out the area of a segment of a circle is that if we take the area of the whole sector and we subtract the area of the triangle part, that will leave the area of the segment. Essentially, whole minus part gives us a part. Okay, so you're going to have a couple different things here that we're going to have to look at. You're going to have to be able to find the area of a sector. You're going to have to be able to find the area of a triangle. And then we're going to use those two things to find the area of a segment. Now, you'll notice as I look at these two examples, we're going to start with the bottom one. And the reason, I'll tell you the reason here in a second, but we're going to start with this bottom one. So we want to find the area of the segment from P to R to the outside of the circle. So essentially we want to find this area right here, this colored in area. Okay, we want to find that area. So a couple things we need to do. We need to figure out what is the area of the sector and what is the area of the triangle. Now remember, the area of the sector is the arc divided by 360 times the area of the circle. Okay, so as you'll notice in this picture, you'll notice the central angle here is 90 degrees, which means arc PR is 90. So we're going to take 90. We're going to divide that by 360. We're going to take that times, in this case, pi, and the radius is 4, and we're going to square it. So pi r squared. Okay, well, if I simplify this, and all I'm going to do in this case is take 90 divided by 360. I get 0.25. We're going to take that times pi times 4 squared is 16. Well, 0.25 times 16 is 4. So this is really 4 times pi. 4 times pi, if I figure that out rounded to the nearest tenth, is 12.6. And in this case, it is meters squared. So the area of the sector is 12.6 meters squared. That's the area from P to Q to R around the outside of the circle. That's the whole thing. Okay, now the area of the triangle. If you remember, the area of a triangle is base times height divided by 2. Okay, Now, as you look at the triangle, you'll notice that it's a 90-degree triangle. And if you remember when we talked about 90-degree triangles, that anytime you have a 90-degree triangle, the two legs make up the base and the height. Well, in this case, both the legs are a radius, so they're both 4 meters long. So when I go to calculate the area here of the triangle, it's 4 times 4 divided by 2. Well, that is 16 divided by 2, which is 8 meters squared. So the area of the triangle is 8 meters squared. Now, how do I find the area of the segment? The area of the segment is equal to the area of the sector, which is 12.6 meters squared, minus the area of the triangle, which is 8 meters squared. Well, if I subtract those, the area of this segment is 4.6 meters squared. Now, you're going to find out as you go through these that it is very important to keep yourself organized. You'll notice how I went through and did the area of the segment, the area of the sector, and then I did the area of the triangle, and then we found it with the area of the segment. It's going to be important that you're showing your work on these. It's very similar to this, so you can keep yourself organized. Okay, let's take a look at the second one here, the one above this. And the reason that I left this one to the last part is because you'll notice in your triangle, it's a little bit different. We don't have a 90-degree triangle, so you're going to have to figure some things out here. So, as we look at this, let's start with the area of the sector. Again, area of the sector, the degrees is from A to B. The arc AB is 60 degrees. So it's 60 divided by 360 times pi times the radius in this case is 18 squared. Okay? 60 divided by 360 is 1/6. And if I were you, I would just take and make that a decimal on your calculator. And 18 squared is 324. Whatever the decimal is for 1/6 times 324 times pi. So when I multiply all three of those together, I end up with 169.6. In this case, inches squared. Okay, so we found the area of the sector. Again, remember, that's the area of A to C to B and around. Okay, that's the area of the whole piece. Now, when I look at this here, I'm going to try and figure out the triangle. Now, you'll notice again the triangle is a triangle that has 60 degrees on it. This would be C, this would be A, this would be B. Okay. And what you'll notice is we don't have a height of the triangle, but we can draw the height. Remember the altitude here. That creates a 90-degree angle, which would mean that this is 30 degrees, which would mean then we have a 30, 60, 90 triangle. So remember what I said about 30, 60, 90s, they're all going to keep plying in here. Well, I know from C to B, this is 18 inches. The whole thing is 18 inches, which means that part of this is 9. Okay? And what you're going to find out, in this case, it's an equilateral triangle, so I know that that piece is 9 inches. Well, if you remember, I have the short leg. I need to find the long leg. This is the long leg right here. This is the short leg, and that's the hypotenuse. I don't care about the hypotenuse. The hypotenuse we already know is 18. Okay? So we need to figure out the long leg. Well, that's 9 times the square root of 3. Okay? So in this case, my height is 9 times the square root of 3. So when I go to find the area of the triangle, the base of the triangle is 18 times the height, 9 square root of 3, and then we're going to divide that by 2. Well, 18 times 9 square root 3 is 81 square root of 3. And really this becomes 1, that becomes a 9, so it's really 9 times 9, which is 81 square root of 3. If I calculate that to the nearest tenth, that's 140.3, in this case inches squared. So, to find the area of the segment, again, I'm going to take the area of the sector, which is 169.6 inches squared minus the area of the triangle, 140.3 inches squared. And when I subtract those, I end up with the area of the segment to be 29.3 inches squared. Okay, a couple of key things here. Again, you want to keep yourself organized. So this is important that you're writing all this down in your notes so that you understand this is going to be a step-by-step process. Okay? That concludes section 10.7 part 2. Don't forget to complete your WSQ.